Okay, so here are the notes on the last type of systems of equations. This is just the version that's probably the most complex. Okay, so let's go back to easiest. Oops, that's a highlighter. So easiest version is if I have 3x plus 2y equals 6, and I have a negative 3x minus 4y equals 10. They're already set up where the coefficients are opposite signs and they're the same value. Okay, then we have the medium level difficulty where I need to maybe multiply one of the equations. So I have 3x plus 2y equals 6, but maybe I have negative 6x minus 8y equals 20, negative 20, okay, where I don't have any of the values that are the same, but if I took this first equation and multiplied it by 2, what would happen is that I would get a 6x, which then would eliminate here, okay? So this is the medium level where you have to multiply one equation. Okay, so now today with the hardest level is you're going to have to multiply both equations. Step number 1 is you want to make sure your equations are in standard form. So that's your ax plus by equals c, where x and y are on the same side and the constant is on the right. For step 2, you get to pick a variable to eliminate. So you get to decide. Okay, you get to decide which one that you are trying to eliminate. So it can be x or it could be y. Okay, then you are going to have to multiply both equations to get opposite coefficients. So I want them to be the same number, different signs. So maybe a positive 4 and a negative 4. Let's say it's x. Or 3y and negative 3y. Okay, opposite coefficients for the same variable. After we eliminate and solve, we're going to plug back in to find the other variable. And then as always, write your solution, or find your solution, find your solution and write as an ordered pair. Okay, so let's take a look. So in example number 1, we have 7 and 5, 12 and 8. 7 doesn't multiply to get 5. 5 doesn't multiply to get 7. 8 doesn't multiply to get 12, and 12 doesn't multiply to get 8. So I can't just multiply one of the equations. I have to multiply both. This is where we want to find the least common multiple of one of the values. Okay, so pick a variable. I don't care which variable. So I'm going to say let's eliminate the y's. So if I decide that I want to eliminate the y's, what I'm going to do is I'm going to find a number that 12 and 8 have in common. So the LCM of 12 and 8. Well, if I list out the multiples of 12, I have 12, 24, 36, 48. If I list out the multiples of 8, I have 8, 16, 24, and 32. What number's on both lists? 24. So if I multiply the top equation by 2, 2 times 12 is 24. If I multiply the bottom equation by 3, 3 times 8 is 24. Now the problem is they're both negative, so I need to pay attention to that as well, and I want one positive and one negative. So what I'm going to do is I'm going to multiply the top by -2 and leave the bottom as a +3. Okay, so when I multiply, I get -14x, +24y equals a +44. Okay, I just multiplied everything by -2. In the bottom system, 15x minus 24y is equal to -42. So the numbers are going to get larger, but watch what happens. When you add these together, -14x plus 15x is just 1x. -24 and +24 eliminate. 44 and -42 becomes 2. So now we get a nice easy answer for x. Now you can pick which equation you want to go ahead and plug it back into. I'm going to do the second. So 5 times 2 minus 8y is equal to -14. So 10 minus 8y equals -14. -8y, if I subtract, is going to, minus 10. We get -24, and dividing by -8, y equals 3. So your system has 2, 3 as the solution. Okay, so we just had to make sure that we multiply to get the least common multiple. You don't always have to use the least common multiple. If you can multiply to get the numbers the same, it's always going to work out. Just your numbers tend to get large. Okay, so if I look at the next example, 2 and 3 are pretty easy. So 2 doesn't multiply to give 3, and 3 doesn't multiply to get 2. 3 doesn't multiply to get 4, and 4 doesn't multiply to get 3. So I'm going to have to multiply both of these equations. You have to decide, what do you want to eliminate. Well, let's suppose I want to eliminate a. So I decide I'm going to eliminate a. I know that 2 and 3, so if I look at the LCM of 2 and 3, 3 is 3, 6, 9, 12. 2 is 2, 4, 6, 8, 10. Oops, I missed one. 2, 4, 6, 8, 10. 6 is on both lists. So if I multiply something times 3, so 2 times 3 is 6. So I'm trying to get a 6a. And I want a positive 6a and a negative 6a. So right now I have a positive 6a. If I multiply 2 by -3, that's going to give me a negative 6a. Okay, so what I have now, if I multiply, is 6a plus 8b is equal to -50. And now I have negative 6a plus 9b is equal to -18. So if I add them together, I don't want to do that. That would be Christmas colors. Let's do blue. Add them together. So those eliminate. I have 17b is equal to -68. And if I divide, I get b equals -4. Go ahead and plug them back into whichever one you like. I like the second one better. So I'm going to do 2a minus 3 times -4 plus equals 6. So we have 2a plus 12 equals 6. 2a, if I subtract 12 from both sides, equals -6. So a equals -3. So solution -3, -4. And there's your solution. Okay, so finding the systems is not that difficult. We're just multiplying both equations.